Hello. Wasn't expecting to have to use a handheld mic. That's fine. Cool. Thanks for coming. My name's Sam Hindmarsh, and this talk is going to be going over my experience with getting onboarded with Kotlin Multiplatform Mobile, KMM, and trying to convert an existing app to use KMM. So I've been an Android developer for about 8 or 9 years now. I'm currently contracting for an agency called Dovetail, and I'm working on a project for Afterpay. But I'm not going to be talking about any of them today. I'm going to be talking about migrating one of my existing side projects to KMM. So for context, I have about 4 weekends worth of experience with KMM. So I guess you could call me an expert on the subject. That was a joke, by the way. Thanks. So why KMM? So you might want to use KMM if you want your if you want to use a. Right, 1 second. There we go. Now I can read what I'm saying. You might want to use KMM if you want a write once, run anywhere type app. You may want to use KMM if you want your business logic to be consistent across your Android and iOS apps. So in that example, you might have a dedicated team of Android developers and a dedicated team of iOS developers, and you have otherwise native apps. But maybe you have some complex business logic, some sort of proprietary algorithm or some sort of data layer with an integration that you might want to share. And you may want to use KMM if you're an Android developer and you want to be able to deploy your app to iOS devices. And it's worth pointing out that even if you don't use a Mac, you can still write the shared code and the Android code on a non-Mac machine, which can be useful if you're running an old MacBook like I am. The only thing is you can't write your iOS-specific Kotlin without a Mac because the standard iOS libraries won't be available. So without getting too much into the technical details of how this works, essentially you create your shared module in Android Studio, you add the shared module to the iOS app using CocoaPods, and you add the shared module to Android using the build.gradle. And this all kind of worked pretty smoothly. Like this part's pretty good. Foreshadowing. So the next step was to create the project in Xcode, and then add the shared module to the pod file, and add the pod file back to the shared module. And by doing this, it basically means that when you do a sync in Android Studio, that will ensure that the latest version of the shared module is accessible via inside Xcode. And so the interoperability works pretty well. You just need to remember to sync Android Studio when you make changes to the shared module. But they're pretty quick. Although if you do change dependencies, rebuild can take about 10-15 minutes. But, pretty par for the course. So at this point, I was basically left with this structure. So I have my Android project, which has 2 modules, the app module, which contains all my standard sort of Android code, and a shared module, which contains 3 source sets, Android main, iOS main, which are the platform-specific Kotlin, and common main, which is the actually shared stuff. And the iOS project lives outside the Android project and is just a standard iOS project. So in terms of workflow, basically Xcode is used to build your iOS UI and integrate your shared module. And then Android Studio is basically everything else. So writing your Android UI, writing your shared module code, and writing iOS-specific code in Kotlin. So migrating the first feature. So this feature is basically a feature to show a list of exercises inside the app. And like I mentioned earlier, I'm going to start trying to migrate this feature from the bottom up. So that basically involves migrating the data layer, which includes a Firestore DAO and a storage DAO. There are no Firebase functions in this feature. So my first attempt at migrating the Firestore's data access object was to use the expect class functionality of Kotlin. So expect classes are basically like interfaces in that they are a promise to fulfill certain functions. But when you're using an expect class, the actual class, which is the implementation, the concrete implementation, doesn't need to be aware of the expect class. So you don't need to have a concrete reference between the two. You basically have your expect class, which has expect functions and expect properties, and then you fulfill those with an actual class. Or in this case, for Android anyway, you would use an actual type alias, and then they would be type aliased to the standard Firebase classes. So for example, you'd have expect class document reference with all the document reference functions in there, and then you would have actual type alias document reference aliasing the Android implementation of document reference. Hope that made sense. But the problem here is that obviously you need to create an entire hierarchy of expect actual classes for basically every class in the hierarchy of all of Firestore, basically. And obviously this will be flaky, because if you then need to upgrade the Firebase libraries inside your Android app, you need to go back through and fix all of the class changes. So that was kind of a no-go. So my second attempt was to look for a third-party library to solve my problem, and I found this one called Firestore KMP. And under the hood, it works basically exactly by doing the expect actual class solution. But the problem here is that there was a version mismatch with Kotlin Native, in that the library was compiled with Kotlin Native 1.3, and I was trying to use 1.5, and you need to have an exact match when you use third-party libraries. Some more foreshadowing. And so my third attempt and final attempt was using this other third-party library called Firebase Kotlin SDK, which is not too bad. It did most of the job that I needed it to, but it doesn't have 100% API coverage, which is a bit of a problem. And it only supports a Kotlinified version of the SDK. So in my case, so for example, instead of using callbacks, he uses flows. And for me, because trying to convert an existing app, I wasn't using flows, which meant a bunch of refactoring. Cool. So if you remember how I said Firebase Kotlin SDK doesn't have 100% SDK coverage, well, it has 0% coverage for Firebase storage. So for migrating the storage DAO, that was an issue. And so in order to kind of make progress, the temporary solution was basically just to split the repository in two and have a shared repository, which was able to have all the functionality that was provided by the shared library, and a platform-specific repository, which basically did all the Firebase storage interaction. Cool. So the second step of the migration was to migrate the repository. And so we have the Firestore DAO shared, but the storage DAO was still platform specific. And so you can see already that this is not going to work, because obviously the shared repository is not going to be able to access the platform specific repository. So, for now, I needed to basically do the same thing and split the repository in two. So that's shared repository for retrieving the exercises via Firestore, and then platform-specific repositories to retrieve the images. And in this case, you would probably do your iOS platform-specific storage repository in Swift. But as a future improvement, I didn't look into this, but I imagine this would work. You could create an exercise storage delegate class, expect class, and reference that within your single shared repository, and then write your actual storage repository delegate in platform-specific source sets inside the Kotlin shared module. Found another couple of useful libraries here, Moco MVVM and Moco Parcelize, which I believe are developed by the same team that developed KMM, and they basically provide KMM-supported versions of view models in live data and Parcelize. And they were basically drop-in replacements. So just a bit of a side note here. At this stage, I kind of thought that, well, perhaps the better approach is actually just to leave all the Firebase stuff in platform-specific code and only try and share the repository in view model. That would, allow you to not depend on a third-party library to, do your Firebase integration. Yeah, so one requirement of doing it this way, of course, is that you would need to have separate domain layer and data layer models, which Fiddy didn't have, I didn't have as part of this project. So I wasn't able to try this easily. And of course, the downside to this is that you're having to rewrite your Firebase logic twice, right? So you are losing some benefit there, but it may be the only way to kind of do this reliably at the moment. So next step was migrating the view model. And, because we have two repositories, now we need two view models. So shared view model to call the shared repository functions, and a platform-specific view model to call the platform-specific functions. So already kind of as I proceeded, losing more and more appeal of actually using KMM for this scenario. Again, maybe this would have been solved by taking the alternative approach and not trying to share the Firebase integration, but so another part of migrating the view model was replacing the single live events, which, if you're not familiar with single live event, is kind of a common pattern with usage of live data of creating a single event, basically. I think I found a blog post which talked about this, but basically you can replace that with a broadcast channel and expose it as a flow, and pretty much a drop-in replacement. It worked well. And so originally with the view model, I exposed the list of exercises as live data, and that proved to be a mistake because you can't actually consume live data in iOS, and so it needed to be exposed as a flow instead. So this is basically the resulting architecture of my KMM project. And it's not great. You have to maintain two stacks, basically, a shared sort of stack of view models, repository, and data access, and platform-specific stacks. And obviously at this point I hadn't even started on the iOS code. Speaking of. So yeah, creating the iOS app, launched Xcode, and created the UI in Swift UI. For any Android developers who are unfamiliar, Swift UI is very similar to Jetpack Compose. It's a declarative UI framework. It's pretty straightforward to use. There's a great feature called Previews. I assume it's called Previews, which are very similar to what Compose has in that it's an interactive preview that's rendered right in the IDE, so you can test your UI. And they don't seem to work with KMM. So that was disappointing. But yeah, from there, I kind of tried to integrate the shared module code. There were some issues with using enum types in the Firestore models. Pretty straightforward fix was basically just to use strings instead. And then the question became, how do we consume a flow in Swift? And so I found a blog post that basically recommended trying to wrap flow in the Combine framework, which, as far as I understand it, is a similar framework to flows. Don't correct me, iOS developers, please. And this is kind of where I got stuck, which is disappointing. I was never able to actually get the iOS app working. And it's kind of all down to dependency management. It's, all those third-party libraries I was trying to use weren't compatible with each other. So the latest version of coroutines required the latest version of the MVVM library. That seemed to be incompatible with some other library version and refused to build. And at that point, I had basically run out of time because, I only had 4 weekends to kind of learn all this stuff. So, but I do have a few takeaways. Dependency issues. So, as I mentioned, all your dependencies have to be compiled using the same version of Kotlin Native as you're using in your project. But obviously being an alpha, Kotlin Native is constantly getting sort of major updates. And then if, you end up in a situation where library X may require 1.4.3 and library Y requires 1.5.0, that can happen quite often. And if that happens, then you're in trouble. A few other gotchas. As I mentioned, you can develop your shared code on non-macOS systems, but you won't get any code completion in the iOS source set. Kotlin Native uses Objective-C bindings on iOS, and so it means that all dependencies have to also support Objective-C. So you won't be able to use Swift-only libraries. I don't know how many Swift-only libraries exist in iOS, but... and obviously KMM is still an alpha. I had a bad memory leak in code completion at one point and just kept causing Android Studio to freeze. My solution in that case was to go to bed and try again the next day. That seemed to work. So, takeaways. It's probably easier to use KMM if you're starting from scratch with the idea of building a KMM supported app. If you have an existing code base, it needs to be really well architected with a really strong separation of concerns between all your layers. And if you are going to use Firebase, maybe it would be nice to have official KMM support from Google there. So if anyone's listening from Google in the live stream, that'd be. The other thing is you probably do need to learn some iOS development, if only to deal with the issues that come up. I had a couple of issues where I was trying to debug, and turns out debugging iOS is really difficult if you have no idea what you're doing. Who would have thought? Yeah, I was a little bit naive and kind of hoping that I would be able to just build an iOS version of my Android app by using KMM, and it kind of doesn't work that way, unfortunately. So, yeah, I think if you have an existing app that doesn't use KMM, then your best solution might just be to write a native iOS app. If you're going to be learning, a bunch of iOS development anyway. So for me and for Fiddy, I think KMM is probably not going to be the right solution. It's just not architected correctly to use it. So yeah, thank you all for coming. Thanks for listening. If you want the slides with all of these references, they are links. You can follow that link. Yeah, that's it.
Sweet. So for those online, if you have any questions, chuck them in the chat now, and I'll get to you. But does anyone in the audience have any questions?
What would be the easiest way to shut down people who in the business where you work who would say, let's just make a cross-platform app with Kotlin Multiplatform?
I'm not sure if I would necessarily shut that down. Yeah, I mean, obviously, like I said, if you architect your app with Kotlin Multiplatform in mind, I think you could probably do it. It might be worth investigating. I know I kind of, ended by saying that it didn't work for me, essentially, right? But I think there is value there. I think you just need to really know that you're going into a project going to use KMM, and you have to make sure you get stuff right from the get-go. So, yeah, I don't think I would necessarily kind of try and immediately steer people away from KMM if that's, what they want to invest their time into. Yeah. I think it would require a lot more effort, though, I guess that's a warning, right? It's like, it's not just 2 for the price of 1. It's, 2 for the price of 1.5.
So any other questions from here in the audience?
I was going to ask, when you were talking about an alternative architecture where you just did the view model and repository, was that sort of the intent there that those bottom DAO classes would be expect actual interfaces, or was there some other way you were thinking of doing that?
Yes. Yeah. So I think the idea, and again, I didn't try this out because I kind of ran out of time and I'd already committed to doing it this way. But yeah, my thinking was that you could probably have expect actual data layer repositories, and then you would fulfill those using actual implementations in your Android and iOS source sets. The thing that I didn't mention anywhere in the talk, but when you are writing the iOS specific Kotlin in the shared module, you do have access to all the standard iOS libraries. So you would in that instance be able to use the standard Google Firebase iOS SDK. Yeah.
Sweet. Any more questions?
Yeah, just a follow up to that, I guess. With the issues you face as well, and it being an alpha product. Just wondering if you wanted to bring this to production, what other issues could someone potentially face as well? And is it still, I mean, is it mature at this stage in time to actually push it out to a live user base of, say, 1 million people?
I like the mic because it gives me time to think of my answer. Yeah, I mean, I guess instinctively I hear the word alpha and I say no. I probably wouldn't use this in production. So I guess to answer like the earlier question, like that would probably be maybe the pushback to a business of why not to try and, you know, use this in your production app. But in terms of other issues, like it did feel pretty mature. Yeah, all like I kind of mentioned, the tooling all kind of just worked. But even with that, because of the dependency issues, you know, because Kotlin native is still an alpha, I probably wouldn't at this point try and use it in production. I think it'd be too risky.
Cool. I have a question from online from Dave McKelvey saying, thanks, Sam. Any thoughts on using multi-platform to share DTOs/models between mobile and backend, say Ktor?
No. I mean, if you have super complex models, I guess you could probably share them. Yeah, I guess the question then becomes, does the cost of maintaining it in a cross-platform way outweigh, rewriting them for your specific platforms? But yeah, I guess you could do it. Yeah, can't think of any reason off the top of my head. Give me another 4 weekends.
So any more questions in the audience? One more from us.
Given your not 100% positive experience, are you actually going to use those 4 weekends and keep going with this? Or is this sort of the end of the road for Sam and KMM?
It's the end of the road for KMM and Fiddy, I think. I think it's just going to be too much work to try and refactor it at this point to really use KMM. I think I'd like to have another play, I think, with a new code base. And maybe the next side project that I start building and never ship will use KMM. But yeah.
Sweet. And I think we have time for one more question in the audience, if there is any. Right over the back.
So how well supported do you feel with like the library landscape of Kotlin multi-platform? So like when you're using this, suddenly you can't use your OKHTTP or your retrofit. Do you feel like the landscape is mature enough, or do you feel well supported in the community?
Yeah, I mean, I can't say I looked too deeply into it. I just looked for the Firebase stuff, basically. Maybe that's telling, the fact that I sort of struggled with Firebase, given kind of how popular Firebase is. In saying that, it did seem like the developers of KMM, Ice Rock, I think is the name of the team within JetBrains, they had a lot of libraries. Like obviously they had the MVVM stuff and the parcelize, and they had a bunch of others that I didn't use. There did seem to be a lot of cross-platform libraries, and then you always have the fallback option of using the expect actual to use platform-specific libraries. But But yeah, I kind of only looked at Firebase stuff, so I don't really know. But yeah.
Awesome, cool. I think we'll call it there. Big round of applause for Sam. Cool. So thanks to everyone who tuned in online. We did have some